let's build a custom layout. So we're just going to come in, and the first thing we're going to do is we're going to create our composable function. This is called diagonal. Diagonal. And this is going to take your composables, children, and it's going to put them down in a diagonal manner towards the edge of the screen. So the first thing you're going to do is you're going to say layout, and then you're going to remember that you also have to pass a modifier and some content, and that content is your composable content, and that's those things which you're going to give to this layout. It needs your content and it needs your modifier, and then what's going to come out is measure scope, and what you can get there are your measurables and your constraints. And so the measurables are your children, whatever you're passing into this layout, and the constraints are the constraints for this layout. So I don't know, fill max width, fill max height, fill max size, that kind of stuff. And so what you're gonna do, we're gonna do this kind of super easy, super simple, not overcomplicate things. And so, sorry, that bothers me. So how do you go from a measurable to something you can place on screen? Well, you gotta measure it, because it's measurable, it's not measured. So what we're going to do is we are going to get something called placeables. And the way you get placeables is by measuring your measurables. Dot measure, pass in the constraints. Now, this is kind of weird. I always made this mistake when I was first doing this. These constraints that you're passing in, right? These are the constraints of the entire layout, right? And so I made the mistake of always passing in the constraints of the entire layout to the children of the layout, which always led me to be confused as to why each child was taking up the entire space. But really, what you want to do is you want to give a min width of 0 and a min height of 0, and that way your composable can your child composable can just take up the space that it wants, right? And now what we're going to do is we're going to call the layout function, and the layout function is going to take the constraints dot max width and constraints dot max height. Now you could calculate these values. Let's say that you only wanted your composable to take up the space that its children took up. So like in a row, the row is only going to take up as much space horizontally as many children you give it, unless you specifically say fill max width or size. It's only going to take up as much space as its children need. And so you could do that too. You could calculate that width and that height, but for simplicity's sake, we're not going to. And then what you're going to want to do, sorry, let me get rid of that. What you're going to want to do is, now we have these placeables. What's a placeable? It is a child. It's been measured, and now it can be placed on screen. And you do that by calling placeable. Well, first we're going to loop through all of our placeables, and we're going to say placeable dot place. And now you need to know where you want to place it. So it's going to take an X position and a Y position, and it will also take a Z position. And there's actually several different place functions. So you can do place, relative, and so relative is going to take into account things like right to left. But for this one, we're just going to do place, and we're going to have to calculate where each of these is going to be on screen. So we are going to keep a, caps lock on. We are going to keep a running height and a running width. And so we are just going to place these at X at width, Y at height. And then all we're going to do right now is we're going to assume that for this layout, you just want every child to be placed exactly like on the corner of the previous child, which means that you just want it to be exactly height and width over to the side when you're placing it. So we're just going to say height plus equals dot height, it being the placeable, and width plus equals it dot width. Excellent. And so now let's throw some things into this layout. Let's call diagonal. We're gonna tell it to fill max width. No, fill max size actually. And then let's just do repeat 10 times, and it'll be a box with a background. We'll say cyan. That'll be pretty. And we'll give it a size of, I don't know. Why is this the hardest part? 40 dp. That seems big. 24 dp. How about that? And let's build it. Hey, it worked. Sorry if you can hear my computer. Sounds like a rocket ship taking off. Anyways, yeah, so you can see here that one thing you have to remember is 0, 0 in Android is the top left corner, and Y goes up as you go down, but X goes up as you go to the right, like you would expect. So it's like you're in quadrant 4 of a normal coordinate system. But yeah, so as you can see here, this is our layout, and I put boxes here, but you could put anything here. You could say text. Well, that's not what I wanted at all. You want to import material 3 text equals, I'll just say I'm it. Yeah, so you can place anything here, and it will lay it out in a diagonal. If you wanted to, you could add additional parameters here, something like I don't know, layout direction or alignment or arrangement, and you could add custom handling for all of that. Another thing that I feel like I should probably go over is, what if you want to have a modifier that you can apply to the children of this composable within that scope? So something like, if you're in a box, you can do dot align, and the box knows how to handle that. Well, you can do your own custom ones. So let's do diagonal scope. Nailed it. I should probably make it a data class. Diagonal scope. And you're supposed to do a layout scope marker on that. And then scope. Excellent. I made a data class, but it doesn't actually have to be can't be a data class. I'm not putting any data in it. Anyways, and what you're gonna want to do also is create this can be a data class, and it'll be the diagonal child data. And this one I'm gonna call this is gonna kind of be a contrived use case just for the sake of showing you what it looks like. But you're gonna make a class, and it's going to inherit from parent.modifier, and then it'll know that it needs to implement the modifier data, and all you're gonna do is say equals this at diagonal child data, and for some reason that's required. I don't know, because it's gonna be this every single time. Maybe there's sometimes when you do other things. I have no idea. And now you're gonna make an extension function for modifier dot, I'm gonna call this selected, and it'll take in a boolean, and it's gonna be equal to then diagonal child data, and select is going to be the excellent. And then what you have to do is, now that you have a diagonal scope, you have to apply that diagonal scope to the function you call in, and now it'll say, hey, there's no layout function like this, and that's because no content. equals at composable. That's because now it's like, this isn't just a composable, this is a diagonal scope composable. Anyways, so now you're going to instantiate diagonal scope and then call content on it. Now you have your diagonal content. Excellent. And so now, actually, if we come back up here, you will see that we get this diagonal scope. I'm recording, right? If we come back up here, you'll see that we get this diagonal scope. And so now it'll know if the correct... Well, now you have your diagonal scope. So you can here modifier equals modifier dot, and it will know to look for the selected modifier. And I'm going to say selected if it equals 4. I'm also going to change this back to a box. And so what I'm going to do here is you can now access this parent data while you're in this measure scope. And the way you can do that is you have your placeable, and it has this parent data, and you can say parent data as, and ours is called diagonal child data. I guess I should call it diagonal parent data, whatever. And we'll do that nullable just in case somebody doesn't actually use the modifier. And you can say dot select. And so we're going to say selected equals that or false. And then I'm going to do place relative with layer. And now I actually have access to the graphics layer. And so I can do something like alter the rotation Z. And so I'll say if selected rotation Z is 90, else it's 0. Are those? Yeah, sure. And then now if I run the app, all right, so it worked, but I forgot that if you turn a square 90 degrees, it looks like a square still. So we're gonna do 45 degrees, and I should just be using a preview, but I'm not, and so I'm just gonna build the app and wait another 3 minutes. Sweet. So yeah, like I said, I set the index 4, which will be the 5th item, to have a different rotation, and that's exactly what we see. So yeah, this is one way that you can pass data from your child to the parent layout, right? And that's really powerful. Another thing that you can do is within your scope, something like in a box with constraints. When you're in a box with constraints scope, you have access to the max width, the max height, all that stuff. You can do something similar. So if you make your scope into a class, I just like using data classes, but if it has, maybe it has, it exposes the child count as if you wouldn't know already, but just for educational purposes. And so now you would need some way of storing that child count. Now you can do something like child count equals measurables dot size, and then now when you're in this diagonal scope, you can, I'll just do a text as the first thing, and it will say child count, and you can now access the child count. And so it should actually be 11, right? So let's see. Anyways, so I got fed up with waiting for the app to build, so I just made a preview. And something weird that I saw is that without going into interactive mode, the child count stays 0, like its initial state. But then as soon as you do interactive mode, it goes to the actual child count, which is 11. So that's really interesting. I don't know why that happens. Sweet, that was custom layouts. I hope you learned something. I did. I learned that I'm bad at making videos. See you next time. Watch this. Watch this video I've made.